Okay, so this is the volume of spheres unit. This is week 9, lesson 1, and this is chapter 8.4 if you're using your textbook. Okay, so for volume of spheres, this part is a little bit different than what you see in the textbook. We're just going to find the volume of the sphere of this gumball machine. So the sphere part is where the gumballs actually are. Remember, volume is how much can go on the inside, and surface area is how much is on the outside. So we want to know how much room is on the inside of that globe that the gumballs are going to fit into. So here is the equation for volume of spheres. So it's V equals 4/3 pi r cubed. So in this one, we can list out what we know. And this, all we know is that the radius equals 6 inches. Okay, I always like to make a little list on the side of what they give me. That way I can figure out what I need to find. And obviously we need to find the volume. So volume equals what? All right, so if I go through and I fill in everything I know, I'm not sure what the volume is. So I'm going to put volume equals 4/3. And instead of writing pi, we can put in 3.14. You can use 3.14 for pi anytime unless it tells you to use a different number. Sometimes it has you put in 22/7, but most cases you're going to use 3.14. Okay, and then r is our radius, which we say is 6. Okay, now looking at this, we need to decide what we're going to do first. So remember your order of operations. You have please excuse my dear Aunt Sally. Okay, that's our order of operations. P stands for parentheses. If we look inside the parentheses, we have 3.14 and we have 6. There's no operations for us to do. Okay, they're just numbers inside. So now we're going to go down to the E, which stands for exponents. We do have an exponent. We have 6 to the 3rd power. So 6 to the 3rd power, that means 6 times 6 times 6, which is 216. Okay, and then I'm going to bring down everything else that we did not use. Okay, now after exponents, we have multiplication and division. So in this case, this is all being multiplied. 4/3 times 3.14 times 216. Okay, so you can put all of that in your calculator. I recommend putting parentheses around each piece. Okay, you can use the calculator on desmos.com/scientific, or you could do it in 2 pieces, and that's what I'm going to do. So I'm going to take these 2 numbers here and multiply them together. 3.14 times 216, okay? And then I'm going to do the 4/3. All right, let me grab my calculator real quick. And we're going to see what 3.14 times 216 equals. All right, 3.14 times 216, that is 678.24. Okay, so again, if you want to put in the calculator, you can put 4/3 in parentheses, or you can do 4 divided by 3, enter, times 678.24. Whatever works for you. Or you could take this number, multiply it by 4, and then divide by 3. So there's a lot of different ways you can get to your answer, but when you do multiply that out, you get the volume of 904.32. Our unit is inches, and anytime we talk about volume, it has to be cubed. Surface area is squared, volume is always cubed. Okay, so like I said, you can find this a couple different ways. 4 divided by 3, enter, times 678.24, or you can do 678.24 times 4 divided by 3. Okay, so go ahead and pause the video. I would like you guys to see if you can figure out this. Be careful of what they give you. All right, come back and check the answers. All right, so hopefully you had a chance to solve this one on your own. All right, again, I'm going to make a list of what they give me. So they say, what is the volume of the ball with a diameter of 6 centimeters? So I know the diameter is 6 centimeters. And we want to know what the volume is. Okay? And they say to use 3.14 for pi. So pi equals 3.14. Now, here's the thing, though. In our equation over here, we don't have a D for diameter. We have an R for radius. So I have to figure out if my diameter is 6 centimeters, what is my radius going to be? Okay, and if you remember, the radius is half of the diameter. So if we had a circle, the diameter would be the whole distance across. Okay, the radius is only half of that. So that would be our diameter. And the radius is just half of it. Okay, and that's what we need for this problem. So if the whole distance is 6, half of that would be 3 centimeters. So let's go ahead and substitute everything we know into our equation. So we have V equals 4/3. Pi is 3.14. Radius is 3 cubed. All right, again, thinking about our order of operations, PEMDAS. Please excuse my dear Aunt Sally. Parentheses, there's nothing we can do. Exponents would be 3 to the 3rd power. So that's 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27. Okay? And then we're going to bring down our 4/3 and our 3.14, and we can multiply all of these together. Okay, so again, you can do it in 2 pieces. You can multiply the 2 numbers on the right and then take care of the 4/3, or you can put all 3 of these in parentheses and type them all in at one time. Okay, so once you do that, you get the volume equals 113.04 centimeters cubed. Okay, so this time we want to find the volume given our surface area. So we are saying, what is the volume of the soccer ball, rounded to the nearest whole number, and they provide the surface area. So they tell us the outside, we want the inside. So we have to do this in 2 steps. So the first thing we're going to do is we are going to find the radius using the surface area. Okay, so if you remember, the equation for surface area, we did that a couple weeks ago, for a sphere is 4 pi r squared. Okay, so let's substitute our number that we have here for our surface area into this equation. So I have 1,519.76 is equal to 4. Now we know pi is 3.14. Okay, we don't know our radius, so we're going to leave that alone. All right, so now we need to solve this part right here because we want to get r by itself. So if you type in your calculator 4 times 3.14, we get 12.56 r squared. All right, I'm just bringing everything else down. Now, if I'm looking at this, I want to say, how is the 12.56 connected to the r squared? So how are they attached right now? Well, right now they're being multiplied. So I have to do the inverse operation. So I need to divide both sides by what I want to go away. Okay, because I want this to cancel out, so r squared is by itself. Okay, all right, get out that calculator and we're going to type in 1,519.76 divided by 12.56. Okay, and we should get 121. Now we're really close to having our final answer. Right now, r squared is 121. We need to undo squaring something. So think back a couple weeks when we talked about Pythagorean theorem. When you want to undo squaring something, you take the square root. So whatever you do to one side, you have to do the same thing to the other side. So r squared and our square root cancel out. And we have r equals the square root of 121, which is 11. All right, so now that we know the radius, we should be able to find the volume. So again, think about your equation. Volume equals 4/3 pi r cubed. Okay, that's the new equation we just learned this time around. And we substitute everything we know. We don't know the volume, but we do know we need to keep the 4/3. We know pi is 3.14. And now we know that r is 11. Okay. All right. So if I do 11 to the third power, that's 11 times 11 times 11. Let's see what that is. 11 to the third power is 13. Ooh, sorry about that. 1331 times 3.14 times 4/3. All right, we're just gonna leave the little spike there. All right, and then if you multiply all three of those numbers, you should get 5,572.45 centimeters cubed as our final answer. That's the volume of that soccer ball. So a little bit more work, but nothing that you guys can't handle. All right, so next we need to talk about the different kinds of shapes. So obviously we know a sphere is like a ball, okay? We have a new vocabulary word in this unit, and that is the word hemisphere. And a hemisphere is half of a sphere. So if you think of it, think of a globe or the earth, okay? You know how we have the northern hemisphere and the southern hemisphere? So North America is in the northern hemisphere. So that is if we were to slice the earth in half right at the equator, okay? So whenever we're talking about hemisphere, we're going to use our sphere equation, but we're going to divide it by 2 because it's not the whole thing, it's half of it. So this part is called volume of composite figures. A composite figure is just a combination of 2 or more figures that all form one thing. And we see these all the time in real life, especially here in Cecil County. For this example, they're talking about this corn silo. Okay, there's plenty of these all around our county. So if you look at it, it is a cylinder at the bottom, and then that top, that globe-looking thing at the top, is a hemisphere. So we have 2 pieces. So we have to find the volume of the hemisphere, and we need to find the volume of the cylinder. And then we're going to take the 2 pieces and add them together. So the hemisphere one, if you notice, here is our 4/3 pi r cubed, but then we have to divide our answer by 2 because we only want half of that sphere. So let's go ahead and make a list of everything they give us. So if you're looking at this, the 10 meters is the height of the cylinder. So we could say H equals 10 meters. Now the 4, it's a little hard to tell from this picture, but the 4 is actually the diameter all the way across. So diameter equals 4 meters. Now we know from our equations there's no d there, so we need to find the radius. The radius is half of the diameter, so it would be 2 meters. And of course we know that for pi, we're going to use 3.14. So here's my little list of all of the information that I need for this problem. So let's go ahead and see if we can find the volume of the hemisphere. So we have volume equals 4/3 times 3.14. The radius is 2 to the third power. And then we're going to take the answer and divide it by 2. Okay. So if we go ahead and do 2 to the third power, that's 8. So I have 4/3 I don't know why my computer likes to do that. Times 3.14 times 8 over 2. All right, and then if I go ahead and solve that, multiply all my top, and then divide the answer by 2, I get a volume of 16.75. It'll be meters cubed. All right, so we'll keep that in mind. We're gonna need that in a second. All right, for the cylinder, so that one we need pi r squared times our height. So we have the volume equals 3.14. Our radius we decided was 2 squared times our height, and our height in this case was 10. Okay, all right, well 2 squared is 4, so I have 3.14 times 4 times 10. So if I multiply all three of those together, I get a volume of 125.6 meters cubed. Now, this one wanted us to find the volume of the entire figure. So because we have to figure out the entire figure, we need to add all of our pieces together. So in this case, we're going to do 16.75 plus 125.6. So that's the volume of the top piece and the volume of the bottom piece, and we're going to add the two together. So if you add them up, our total volume is 142.35 meters cubed. Okay, so this is our final answer right here. Okay, so not too bad. Just split the piece up into separate shapes, find the volumes, and then combine them together at the end. All right, so here's your next try it. So you want to find the volume of the composite figure at the right. We have a hemisphere and a cone. So what I did was I went ahead and I gave you the equations here for hemisphere and cone. Pause the video, give it a shot, and then come back and check your answers. All right, so hopefully you had a chance to try these. All right, let's do this hemisphere first. So actually, before we do anything at all, again, I'm going to make a list of what I know. So I know the 2 inches looks like it's half of the circle, so that is my radius. So I can say the radius is 2 inches. And the 6 inches is the height of the cone. Okay, but that's all the information that they give me. All right, and that should be enough because in our equations down the bottom, all we have is r and h. All right, so our hemisphere, we have V equals 4/3. Pi is 3.14. Our r is 2 cubed over 2. Okay. All right, if I go ahead and I do my 2 cubed, well, that's, again, 8. 2 times 2 is 4. 4 times 2 is 8. So we have volume equals 4/3 times 3.14 times 8 over 2. All right, and our final answer after we simplify all of this should be, let's see, 16.75 inches cubed. So that is the volume of the hemisphere. All right, now the cone. So it's been a while since we used this one. This one has the 1/3 in it. So the volume is 1/3 times our pi, which is 3.14, times the radius of 2 squared times our height of 6. Okay, again, I can simplify my exponent. So I have volume is 1/3, 3.14. 2 squared we know is 4 times 6. Now, if you watch my other video, I kind of taught you a little trick. You can simplify all of this part here first. So you can do 3.14 times 4 times 6. And let's see what we get. 3.14 times 4 times 6. We get 75.36. Now, if I want to multiply it by 1/3, instead of multiplying by a fraction, you can divide by 3. So multiplying by 1/3 is the exact same thing as dividing by 3. So if I take 75.36 and divide it by 3, my volume is 25.12 inches cubed. Okay, so now that I have my 2 separate shapes, now I need to figure out the volume of them together. So I'm going to take these 2 pieces and I'm going to add them together. So this one and this one. 16.75 plus 25.12 gives me a total volume for this composite shape of 41.87 inches cubed. Okay. All right, so here is the classwork for this section. It's page 440 and 4 to 442. So a couple pages in there. You're going to do number 2 and then numbers 4 through 13. All right, the exit ticket is page 442, numbers 16 and 17. Remember, the exit tickets need to be turned in for feedback. That's what goes into the grade book. You can do them on Schoology, you can do them on paper, and submit them to me electronically through the Drive or through email, whatever works for you. If you have questions or you need help on any of these problems, I'm available on Blackboard Collaborate.